Hello everybody. I would like to add some bonus material to the videos. I had some thoughts and some issues that I encountered, and maybe it's not going to follow the general path in which the videos are going, but I think it might help to some of you if you got stuck at some point and got confused. So the first thing I would like to discuss, let's make this video of some, let's say, tips and tricks. So the first thing I would like to discuss is, again, how do you get additional information from the robot. So as we talked before, we have the configuration XML file in which we can define different recipes which we are interested in. So for example, as you can see over here, we have the TCP Pulse, TCP speed, but we do not have joint values, so we are unable to get them. So what do we do? Like I talked in the first video that I did, there is an RTDE exchange package website provided by Universal Robot, and you can find there in the robot controller outputs names, types and comments on different recipes that can be used. So in our case we are interested in actual Q, so let's just copy it and go back to our code. Over here we can add additional field, just copy paste it, exchange the name to the name given on the website, so we have actual Q. Now it's very important that we make sure that the type is also according to the recommendations given by the website. So we see that the type is vector 6D, so we go over here, it's vector 6D, and then later on, whenever we do state equals con.receive and state.actual_Q, we are able to access the join values. I will delete it for myself because I don't need it, but this is how you do it. The second thing I would like to talk about is about the speed of communication with the robot. So as you can see over here, in our example control loop that we were provided, the reason probably why you are using RTDE exchange packages is because you want to be able to send commands to the robot every 2 milliseconds, meaning in 500 Hz. So threads in the polyscope help you to do that, and I really highly recommend that you go to the UR-script manual on the E-series and to go to point 1.92, which is about thread scheduling. It explains more about the fact that because you want to communicate in every 2 milliseconds, you need to provide a reference point, let's say if we are using Servoj, every 2 milliseconds. And you need to make sure that the execution of the code is synchronized accordingly to the needs of yours, and so that the robot is able to run with the speed that you want it to run. So by default, RTDE is able to send packages. You have to send packages to the robot, and the robot can receive those every 2 milliseconds. But when you are given the example with the package and you go to the line 64, you will find this line of code that says con.send output setup, state names, state types. So what does it do? It basically allows you to receive the data from the robot. Initially, if you go to the folder of RTDE and script called rtde.py to the line 141, you find a function called send output setup. It takes initially just 2 values as an input. However, I added for myself also one called frequency, and initially it is given as 125. This is the default frequency, which basically tells you how fast are you able to read the values from the robot, because again, as we said, RTDE requires that we send packages every 2 milliseconds to the robot, but if we want to also read with the same speed, we have to change it. So I initialize the value as the default value to 125, like it's given initially, and I extended this function, but later on I will show you an example of my code that I used. You can see, for example, over here that I modified it to have 3 inputs with also input called frequency. and I changed that frequency to 500, which allows me to read the value from the robot at 500 Hz, which is maybe for some of you it's important, so this is how you can do it. Another thing I would like to talk about is the usage of a script manual. This is a very important tool. It basically tells you how the UR script works and what kind of functions can you use. So let's, for example, look at one of the main functions that are being used when dealing with 500 Hz communication. So up to my knowledge, I mean, at least the functions that I have been using, there are blocking functions and non-blocking functions. So blocking functions like move L, for example, we want to move from one point to another. So you tell the robot move from point A to point B, and it's going to wait till this line is executed before the rest of the lines are allowed to be executed. Like in a code, we go from top to bottom till some line gets executed. Only after that we can skip to another one. But this is not the case in at least two functions that I know of, Servoj and force mode. Those are functions that allow us to work with the robot in the real-time rate. So let's talk about Servoj. When I started, it was quite confusing for me how to work with this function. There is a lot of good content on the forum, so I recommend you to go check it out, but let's just quickly go over it and see what we can understand from it. So Servoj, it takes as an input Q. Q is the joint values. So in case of 6 degrees of freedom robot, it's set point of 6 values, and then you have the acceleration and the velocity. Those, as you can find over here, are not being used in current version, so they're both 0. Maybe in the future they will add ability to set them to be different than 0, but for now it's just 0. Then we have T, time, where the command is controlling the robot. The function is blocking for time TS. So because we are sending commands to the robot every 2 milliseconds, meaning at the rate of 500 Hz, we need to set this value to 2 milliseconds. So this is where it's very important to make sure that the code the control loop on your Python is executed faster than 2 milliseconds or at 2 milliseconds. Because if your loop is running slower than that, then the values that will be sent to the robot will not be sent every 500 Hz, which is very problematic, because then you will tell the robot to move from point A to point B with not well sampled, let's say, trajectory, and this is going to crash the program, and the Servoj will not be able to execute the trajectory that you wanted to execute. So basically how we use Servoj is we have point A, we have point B, we want the robot to move from one point to the other one. We plant a trajectory. Trajectory is basically a path from one point to another, sampled every 2 milliseconds, very densely, and at each of this time step we give the robot a new joint position to which we want it to go. So let's say we start with one joint with a value of 1, and then at next time step it's 1.001, etc., till it increases to let's say a joint value of 2. So I hope this is understood. Look ahead time from I left it as a default, and I know many people do the same, but here we can see it's range from 0.03 to 0.2. It smoothens the trajectory with this look ahead time. So if you have some kind of a background in robotics, or you at least understand what PD control is, I think this is important to know in this case. So we are sending joint values to the robot, and we are telling the robot, okay, those are the joint values I want you to go to. Follow those joint values. But the robot is not necessarily, it's a physical system, it's not going to do it perfectly. And maybe there will be deviation, so that's why you use PD control for that. We have two parameters that we can set in order to set in what way do we want to follow the trajectory, whether we want to really stick strongly to it, to control overshoot and undershoot. So we have look ahead time, which is the term corresponding in PD control, and we have also gain, which is a P term of PD control. In order to know how to set it up and the effect of those, I highly recommend you to check some YouTube videos about PD control. This is not a video about it, but those are two functions two scalar values that work in the same way as PD gains. So this is about Servoj. Very useful thing. Let's say if you plan your trajectory in the Cartesian space, you can send the poses to the robot, perform an inverse kinematics on the robot, and then input the joint values that you obtained from the inverse kinematics to the Servoj in order to perform the desired motion. If you have any questions, check out the forum about it or leave the comments down below. I will try to help out. And the last thing I would like to talk about is the following function: get actual TCP Pulse. So whenever we want to obtain a TCP position using our UR script, so as we can see over here, this is an example that I wrote. This is what I use. I have state equals con.receive S1, for example, or TCP1 equals state.actual TCP Pulse. So we access the recipe that we define in XML file. What is very important to note is that there can be a case where if you look at the polyscope, right, or the teaching pendant, whatever you want to call it, you can get different values shown there that you receive from reading the same position using the Python code. And this is because those values that you see on the polyscope are being scaled. So don't worry about it. They probably show this exact same position. However, those values are different. So whenever you see that, for example, it usually happens just with the orientation. So you see that you are, let's say, at point A, and the orientation that you see on the polyscope is different than the one that you receive by using the RTDE communication and reading the TCP pulse. Don't worry about it. The robot is still going to get to the correct point. It's just a matter of scaling for, I don't know, being user-friendly or whatever reason. I'm also not very happy that this is happening. It caused me a lot of troubles, but this is what it is, and there are posts about it on the forum. You can read more about how people came to conclusion that it's being scaled, but I don't think in any robotic application you should really be concerned about it, and it should not affect your code whatsoever. So that's all for this short video. Hope it helped you. Have a good day.